All right, Chapter 9, Topics in Analytic Geometry. So the first thing that we're going to talk about is the circles and the parabolas. So these are your conic sections. I know that you guys have done these last year, so we're going to kind of get back into that and maybe add a little bit to that this year. So what we're going to talk about today is just to recognize a conic as an intersection of a plane and a double napped cone, and we'll have a picture of that here in a minute. Write equations for circles in standard form, write equations of parabolas in standard form, and use the reflective property of parabolas to solve real-life problems. So just a side note, make sure that you are looking for that formula sheet in your Google Classroom. It might be, if you have a way to print it out, that might be easiest too. But all of these formulas are on your formula sheet, and that is in Google Classroom under Chapter 9. So the idea of a conic section, so these are the pictures of those double napped cones, is we have the intersection of a plane and the cone. And so when you have it intersecting, it doesn't have to necessarily be parallel to the horizon. You end up with these different type of sections. So you notice if it goes through both parts, we have these ellipses here, or circles, right? If it just goes through one part, maybe you have a parabola, or through two, maybe you have these hyperbolas. And so that's really what we're going to be talking about in these next few sections. When the plane doesn't pass through the vertex, when the plane passes through the vertex, we have degenerate conics, because we don't end up with that hyperbola or circle or ellipse or parabola. We get a point, a line, or two intersecting lines. So it's almost like we don't really get that shape that we're looking for, and that's what it's called, a degenerate conic. So several ways to approach the conics. You could begin by defining the conics in terms of the intersections of the planes and the cones. That's kind of how it started with the Greeks. Or you could look at it algebraically. So this is kind of that big equation for your algebraic function of a conic, where A, B, C, D, E, and F are constants or are numbers, and then the X's and Y's have to do with your axes. Or we'll look at it just as a collection of points. So here we're going to start with circles. Definition of a circle is a locus of points. More general definition is that all of the points are equidistant from the center. And so in this case, HK is the center. So if we're making a list, we know that HK is the center of the circle. And that the distance r between the center and any point is the radius. So for circles, we can use the distance formula to figure out what the radius is. Because if we know what the center of the circle is, if we know the h and the k, and we know one point on the circle, which would be the x and a y, that's just one point out on the edge of the circle. If we use the distance formula, we would end up with the radius. So remember this right here, that's your distance formula that you may need to use to help you find the radius of your circle. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. And again, remember that h and the k are the center of your circle. So if h and k are 0, if we're at the origin, you just have the x squared plus y squared equals r squared. So let's go through a couple examples here with circles. So this first one, we have the point 1, 4 is on the circle, and the center is at -2, -3. And we want to write the standard form of the equation for the circle. So just as that reminder, your standard form is x minus h squared plus y minus k squared equals r squared. And when we write our equation, we leave the x and the y. So we know our h and our k. Our h is -2 and our k is -3. So we get x minus a -2. So x plus 2 squared plus y plus 3 squared, but we don't know what the radius is. So what we're going to use is the distance formula. So if we use the distance formula to find the radius, remember that radius equaled the square root of your x minus h squared plus y minus k squared, which if you notice is really just this formula right here that you take the square root of. And so here, because we need to solve for r, the x and the y we're going to use is going to come from the point 1, 4. So x is 1, y is 4, so we're going to say the square root of 1, our h is negative 2, so 1 plus 2 squared plus 4 plus 3 squared. So we get r equals the square root of 3 squared, so 9, plus 7 squared, so plus 49. So r is the square root of 58. And so if we're writing our general equation in standard form, we'll go in blue so we know this is the answer. We would say x plus 2 squared plus y plus 3 squared equals r squared. Well, the square root of 58 squared is just 58. And so in the next example, we're going to sketch the circle. Now, in order to sketch the circle, we need to know the radius and the center of the circle. So right now, this is given, this equation is given to us in the kind of that whole big equation, and we need to get it into standard form. So the way we're going to do that is we're going to have to complete the square. So what we're going to do is first start by just getting all of our x's grouped together. So we're going to have x squared minus 6x, and then we're going to leave room because we're going to have to add something to that to complete that particular square with x's. And then we'll have plus y squared minus 2y. We're going to have to complete that squared. And we're going to move this 6 to the other side. So in this first group right here, to create a perfect square trinomial, we have x squared minus 6x. And remember, to that, we add b over 2 squared. So in this one right here, this box right here, we're going to add b over 2 squared. Same thing here, we're going to add our b over 2 squared. So in this case, our b value is 6. So if we add 6 over 2 squared plus, and here we have y squared minus 2y plus b, which is 2. So 2 over 2 squared equals negative 6. Now here's what we have to think about. If we simplify this, we get x squared minus 6x plus 9 plus y squared minus 2y plus 1 equals negative 6. But we added a 9 and we added a 1 to the left, so we still have to add the 9 and add the 1 to the right. And now if we factor, right, x squared minus 6x plus 9, that factors into x minus 3 and x minus 3. Y squareds factor into y minus 1 and y minus 1 equals 4. And so if we go one more step, we get x minus 3 squared plus y minus 1 squared equals 4. And this is that general form, or that standard form of x minus h squared plus y minus k squared equals r squared. So if we look at our equation, we know that the center of our circle is the h and the k. And in this case, h is 3 and k is 1. And because r squared is 4, that would mean that the radius is 2. So when we go to graph this, we have to graph the point 3, 1 as the center. And then from there, the radius 2. So what I would do is just horizontally go out 2, vertically go up 2, out 2, and down 2. And that gives you enough points that you can then just connect those points and draw your circle. And again, this is all labeled down here, so it's obvious what you were trying to do. The next thing in this section is parabolas. So for your parabola, you can either have a vertical parabola or a horizontal parabola. And when they talk about the axis, that's the axis of symmetry with your parabola. So if you were to draw an axis of symmetry, if it's vertical, then your axis would be vertical. If it's horizontal, your axis would be horizontal. And your focus is always inside your parabola. Your vertex is always that maximum or minimum. And this distance from the focus to the vertex, that distance is p. And the distance from the vertex to the directrix is also that same distance as the vertex to the focus. So your standard equations for a parabola, again, the vertex is at hk. So we're circles, we use the center was hk. In parabolas, we're using the vertex as hk. So if we have a vertical axis means that your parabola would open vertically. So your parabola would open vertically, which you have then the x squared equation. So x minus h squared equals 4p times y minus k. If you have a horizontal axis, your parabola would open horizontally, and that's why you have that y squared equation. If it's at the origin, if your vertex lies at the origin, then we don't have to worry about the h and the k, and you would just have one of these two equations. And again, these are all on that formula sheet for you. So these are all your different options for parabolas. Your parabolas can open up or down, and your parabolas could open left or right. So if your p is positive, so if p is positive, then your parabola opens up or to the right, which are towards the positive values. If your p is negative, your parabola would open down or to the left towards the negative values. So that's one way to determine what direction it opens, is just looking at that p value. So for this example, we're just finding the standard equation of the parabola. It says find the standard form of the equation of a parabola with the vertex at the origin, and the focus is on 0, 4. So for me personally, with parabolas, I always think it's easiest just to sketch a quick graph. So if the vertex is at 0, 0, and the focus is at 0, 4, and your parabola always has to open around your focus. The focus is always on the inside of the parabola. So just doing a quick sketch, and my parabola is not accurate, but I can at least see, okay, now I have a vertical parabola that opens up. And so if I go back to my formula sheet with the vertex at the origin for a vertical parabola, I know the general or the standard form is x squared equals 4py. Right? And so with this one, I don't have to find an h and a k because those are 0. All I have to do is figure out p. And remember, p is that distance from the focus to the vertex. And so if I go from the vertex to the focus, I'm going in a positive 4 direction. So p equals 4 in this case. So if I were to write the equation, I would get x squared equals 4 times y, or x squared equals 16y. If you wanted to graph this, you would have to solve for y. So you would have to say y equals x squared over 16. And that would be if you wanted to graph in your calculator, right? Because you would have to have it solved for your y equals. All right, so the next example is we're going to find the focus of the parabola. And remember, the focus is really figuring out that distance from the vertex. It's the p distance from the vertex to the focus. So if we know p and we know the vertex, we could figure out where that focus is. But first, we probably have to figure out where the vertex is. And so if you notice, this isn't in standard form. And so if you think back to what we did with the circles and getting it into standard form by completing the square, we're going to do the same thing here. So what I would start to do first is really just to get rid of your fractions. So to clear your fractions, we're going to multiply everything by -2. So that way the x squared has that positive 1 out front. So we're going to have -2y equals x squared plus 2x minus 1. And so we'll get all the x's to one side, and we'll keep the y's on the other side. Because again, remember with parabolas, when we have that x squared in this case, right, we can notice that we have x squared in our equation, which means we're going to use our standard form is going to be the x minus h squared equals 4p times y minus k. So that's the form we want. So we want the x's on one side and then everything else on the other. So if we leave that x squared plus 2x on one side and we move the 1 over, so if I add 1 to the other side, I have 1 minus 2y equals x squared plus 2x. Right? And here I want to complete the square, because I have this right here, that x minus something quantity squared. So I'm going to complete this square. So remember, I add that b over 2 squared. So if I have 1 minus 2y, I have x squared plus 2x plus 2 over 2 squared. Or I have 1 minus 2y equals x squared plus 2x plus 1. So if I'm adding 1 to the right, I also have to add 1 to the left, which means I have 2 minus 2y. And over here, this is going to factor into your x plus 1 times x plus 1, which is x plus 1 squared. So we're really close to having this, but we just need that y minus k. And so here, if we factored out a -2, we'd be left with -1 plus y equals x plus 1 squared. Or we could rewrite it as -2 times y minus 1 equals x plus 1 squared. So now that we're in this form, we know that we have our h, right? Our h and our k. So we know that h is -1 and k is +1, right? Because that comes from your h and your k. H is always with the x, k is with the y. And then we know that this front number right here, if we look back at that standard form, this -2 is really what 4p equals. So if 4p equals -2, then that means that P equals negative 1/2. Okay, and again, visually, if you were to draw this parabola, and P is negative, so we know that it's a vertical parabola. P is negative, so it has to open down. It has a vertex at negative 1, 1, right? And then our focus, it tells us the P is negative 1/2, so the halfway would be where the focus is, halfway down. Or our focus, you could think about being your H value, right? So your focus, our X coordinate stays the same, but our Y coordinate, which was 1 for the vertex, and we have to subtract 1/2. So we were at 1, negative 1, and 1/2 for the focus, right? Because our parabola would do something like that, where this distance from here to here is negative 1/2, because that was your P value. All right, for example 6, we're going to write standard form of the equation of a parabola with the vertex 1, 3 and the focus 1, 5. So again, it might help visually to draw this. So 1, 2, 3, 4, 5. So if we have the vertex at 1, 3 and the focus at 1, 5, we know our parabola has to go through the vertex and open around the focus. And so our standard form, we're going to use the x minus h squared equals 4p times k minus y. Sorry, not k minus y. Y minus k. Right, because we have that vertical parabola. And so we have our vertex. If our vertex is 1, 3, we know that that's our h and our k. So we have x minus 1 squared equals 4p times y minus 3. And remember, p is how far did you go from the vertex to the focus, right? So our p value, we went from 3 to 5, so our p value would be 2. And so we could say x minus 1 squared equals 4 times 2 times y minus 3. Or our general equation would be x minus 1 squared equals 8 times y minus 3. So that would be our standard form. And the last slide here is just kind of the reflective property of parabolas. So parabolas occur kind of all over the place. Some ways you might see it are like with telescopes, that what happens is that if the light is coming in and all the stuff is coming in, then what happens is the parabola, if your light was coming in this way, this parabola is shaped so that it reflects every bit coming in back to the focus, and it's all collected there. Like that's how a satellite dish would work. The parabola is shaped just right so it collects all the signals and it puts them all right to the focus, which is that point that sits up on your satellite dish, and that's where that signal is received. The same thing works the opposite way, is that if light is coming out, like a flashlight, if light is coming out of the focus, it will be put out in all different directions. But when it hits that parabola, which is that part of the flashlight, it all comes back out in a straight line. And that's why you have that straight light coming out of your flashlight. So just kind of something interesting on how parabolas are actually used on a daily basis.